Thanks, everybody. Welcome to this month's Motherval Demo Days. It's going to be one of two in December. I'm excited to share that we have 4 demos from ConsensusLab, BedRock, and Lotus. If you're new here and you don't know what Motherval Demo Days is, it's an opportunity for the Starfleet teams to get together to share progress in their projects in the format of a demo. So a few more things before we start. We would love to get your feedback, thoughts, suggestions on how we can make Motherval Demo Days better. So I'm going to plug in a survey in the chat, and then let's see. For all the presenters, please have your cameras on and we will get started. And Alfonso, are you ready to take it away?
So today I want to demo Spacenet. For those of you that are not aware, Spacenet is a new Filecoin testnet that we launched on Monday. And it's not yet another Filecoin testnet, because what we're doing with this testnet is that we replace the consensus algorithm. So we take out Filecoin expected consensus and we include a framework that it's Mir to implement distributed like SMR systems, and like the implementation of the consensus algorithm that we use here is Trantor over this framework called Mir. What does this gives us? It gives us like faster block times. So we manage, and you'll see in a moment, we manage to create new blocks in less than a second, and also faster finality times. If you want to start like learning more about Spacenet and how to use it, how to interact with it, and so on, we have this repo, ConsensusLab Spacenet, and here you have a link to the faucet, a link to the Genesis block, the bootstraps, and a description of what is Spacenet, the SLA of the network. Of course, don't expect like 100% uptime. Hopefully, we will have a 100% uptime, but this is still a testnet. And how to get started as a user. If you wanna, like right now, the only thing that you can do is exchange Filecoin, and if you are an adventure individual, you can try and onboard power. But like apart from that, until FVM support comes, you won't be able to do much. But that being said, you can start like running your own full node, getting your Spacenet Filecoin, and so on. So this is the link of the repo. And if I'm gonna show you now, I don't know how to share the whole screen. Probably, I hope that you can see my whole screen because I have a wide screen. But what I want to show you is an example of how I'm gonna get some test Filecoin from the faucet. So here is one of the full nodes that I'm running, and you can see that well, like blocks come fast. So, I mean, we could go into the details of how the consensus algorithm works, but every validator, we have 4 validators. Every validator, they have a segment length to propose a new block. And you see that here, every second, we are receiving like 4 blocks proposed and agreed upon between all of the validators. And running add another terminal. So running a new full node to Spacenet is as simple as like downloading our fork of Lotus, compiling it with make Spacenet. So I'm gonna wait for Lotus to finish at least. Apart from Lotus, here we also provide, in case you want to test it, the Mir validator, in case you want to run a Mir validator and so on. And we have everything. Sorry, I was testing. So we have everything configured, and with like just running Lotus with the bootstrap equals true, we have all of the compilation flags that should connect to the bootstrap and start getting blocks from Spacenet. But like, as I've mentioned in the all hands, syncing a full node may be slow because we're already over block 1 million. So I'm going to show you the learner that I have already synced. And here what we're going to test is getting some test Filecoins. So
sorry to interrupt.
Yeah.
Can you zoom in a bit so we can
Yes,
I can actually read?
Okay, let's try the
Thanks.
following. Yeah. Sorry, I have this white screen and like sharing it's a nightmare. So yeah, I was saying that here we have a wallet, and what we're gonna do is test the faucet to see how we are sending some Filecoins to our, like providing some Filecoins to our wallet through the faucet, and so that you can get a sense of how fast this is. So we go to the faucet, we put our address, and hopefully, like, as we have these almost instant finality and fast consensus, we have our time Filecoins here, and we would be able to just start interacting with it away from here. So we could like create this one. So we have now the two addresses, and now I could start like interacting directly through Lotus. Let's see how they work. And again, if you're used to using Lotus in any way, you will realize that this is way faster. Again, we have almost instant finality and less than a second block times. So this is Spacenet. What you can expect in the future is FVM support, dynamic validators. So we're going to start opening new validators for other like external entities from ConsensusLab to join. And yeah, and hopefully IPC soon in Spacenet in a few months. And that's all from my side. Thank you.
Awesome. Thanks so much for sharing, Alfonso. All right, take it away.
This is a example of the AT protocol, which is the work that Blue Sky has been doing. And there are now starting to be examples of servers that are implementing this Blue Sky-like protocol, which is sort of meant as a federated Twitter, but with some better properties about user ownership. And one of the interesting things that they're doing is they're using a lot of our IPLD stack. And in fact, you can export the whole set of tweets that a user has in the form of a CAR file. And this is part of the portability story, where a user, if they don't like the server that they're using to host and maintain their data, they can take their whole history of tweets and move it to another server. And using DIDs, their current location can sort of be updated. So you have less sort of feudalism than Mastodon does in this protocol, which is a nice thing. But with that, we need to think about what tooling is useful to help make this sort of thing work well. So we've had already a CAR binary for quite a while. This hopefully goes away. And so I can take a look at the CAR file that exports, and I can CAR ls it. This is the download from that thing. And we can see that it's got a bunch of blocks in it. And in fact, I can use the -v flag here to see that they're all DAG CBOR. So this is all just like binary data. And so it's hard to see what's actually going on inside of here. So recently we added a new subcommand that you can use, which is CAR debug. And so we can debug this, this file. And what this does is it takes all of the blocks and it re-encodes them into JSON and pretty prints them so that you can see. It's structured in a way that you can actually put it through one of your standard Delta diff things to get a sort of nicer view of this. So it's showing each of these blocks in DAG JSON and what actually is sort of contained and all of the tweets and the set of things. And so you can do this, and you can even pull it into let's see if I can get this into a new window. Oh, I can't, but I'll move this whole thing over. So this is in a text editor. And the nice thing here is I can take this, I can say, oh, I want to change one of these, tweets from my history just to see what happens as this happens. So, you change prop blocks, you get your modified DAG, and then you can CAR compile. And this will not only convert it back into the original DAG CBOR that it was in, but it'll also look at, as it compiles these things back into CBOR, what the block has become because it may be modified, and then it'll find references and change the whole DAG tree back so that the tree lines up. In this case, there's extra work you have to do to make sure signatures still line up, but this combination of debug and compile is enough to get a lot of that sort of manual effort that happens around the CAR format to go away. So we're hoping to see this get used in things like org mode, where your editor can just directly start editing CAR files a little bit more easily and see what's inside of them, and in general improve the tooling around CAR files. Cool. I think that's what I've got. Thank you.
Awesome. Thanks so much, Will. And we have the other Will's demo, and George will be playing it for us.
Hello everyone, today I'll be just do a quick demo on our IPC actors. Basically, it's a user-defined IPC that's running on FVM. I will show you a very simple system architecture, like how everything works together. So first we have the IPC subnet. So basically it's an abstraction of the subnet itself, and it tracks the state of a subnet, such as the checkpoints and the stakes. And at the same time, it manages the membership functions of the subnet, like if you want to join a subnet or quit or leave a subnet, for example, it's all done through the subnets by the subnets. And then, of course, we have the IPC gateway. So what it does is basically coordinate between all the subnets and all the handles, all the subnet interaction. So in this case, for example, such as subnet A sends a message to subnet B. So this is all done through the IPC gateway. At the same time, it maintains the information of the different subnets, like how many there are. At the same time, also it makes sure that the subnets actually follow the protocol. So overall, the subnet IPC gateway will handle the basically multiple subnets simultaneously. So later for the demo, probably I'll just show you how we deploy an IPC gateway on FVM. At the same time, we'll deploy a subnet, and that we can interact with with each other. The gateway interact with the gateway, with the subnets. Okay, so now I'll jump over to my code, to our IDE. So the current setup, we have a node that's already running. And at the same time, also have the a miner that's running. So because the VM is quite small, so probably we don't expect a very high block production time. So anyway, it shouldn't affect our demo. And then I have another one that's currently running, and then this is where we can do all our operations. So let me just quickly show you this IPC as well. Yeah, so we have two. One is the IPC gateway and the IPC subnet actor. And there are repo actually in here. ConsensusLab, feel free to check them out. And we have the gateway, and then we have the subnet actor. Yeah. So this is basically this is the Git where we store our code. Anyway, and then it's compiled to WASM, and then we send it to the machine, and we can do the deployment on the VM. Then because this is actually my cheat sheet. Okay, above actually the how to set up the node on how to set up the FVM. We shouldn't be concerned about that for now. So first I'll install the actor. Of course, we start with IPC gateway. So we just wait for the message to execute, and we should be able to have a message ID. Okay, yeah, okay, code ID. And then it's okay, it doesn't matter. Disregard the variable naming. And then okay, and then we can create the actor and with some parameter. So this parameter is actually the constructor serialized, like CBORD serialized and the base64 encoded. So how it looks like is actually in types. I'm just showing the gateway types. And in the constructor, it takes the network name plus the checkpoint period. So probably you're asking, like, why do you do this in such a low level? Like you have to pass in base64 included. Okay, in the future we'll probably have our own client, like CLI client, but for now, because we haven't, the client is still in progress. So just bear with me for now, and then in the future probably we'll have more convenient tools. So how it was generated is basically a very simple serialization. We just serialize it and just print it, print the serialized version, and that's it. We have this chunk of characters. Okay, now let's just create it and wait for it to be deployed. Okay, just give it some time. Okay, now we just have to be aware of this address. So this is the address of the IPC, and this is basically a different form. Okay, now then what we can do is deploy the subnet actor. Okay, the actor, install the actor. Okay, true. Okay, now we have this ID and then okay, yeah, because we didn't change the code. So and then okay, now we create the subnet actor. So you see here we have another chunk of characters. Similarly, it's the constructor parameter. So with the constructor parameter, like it has a few default parameters and also required, for example, such as the IPC gateway address. So you have to pass in this number so that the subnet actor can actually reach the gateway. At the same time, also we had some minimum validator stake, like you really require some certain amount of stake before you can actually join or make it the subnet live. So how we do this in our simple demo, we just pass in some default values like IPC, like pass in this value. Okay, let me just do it. 1005. Okay, 1005 is the new address, and then we just set some simple parameter, and then just print it. Okay, let's just do it real quick. Okay, if this parameter is wrong, then these actually FVM will just throw an error because the actor cannot be found. Later, we can show us probably a simple demo of this, and then probably we can see the error message. Okay. Okay, this is actually, because I commented off a lot of the code, so it's throwing some unused parameter. But it's just some helper I had it locally, so on the GitHub it should be fine. And then okay, once we paste it here, let's just call it. Okay. Create this subnet actor and then just let it run. Okay, now it's deployed, and I can just call this function now. Call this address with invoke. Okay, now you see. Okay, we created this function because the current Lotus chain invoke. Actually, currently it doesn't have a like a value function, like a value parameter, where because we require like a minimum of, I think a default we require like a 10. So in the protocol, in the IPC protocol, a gateway protocol. So we probably, if we use this one, it will be rejected. So we sort of created our own. It's just a very simple client method that it just attaches the value to it. So it's probably more convenient for our test case. But anyway, like I said before, in the future we'll have our own client. So probably it's more convenient where you don't really have to deal with the seaborg serialization in our Rust code here, but just temporarily for the idea, it's actually the same idea. Okay, now let's just say we have 10. I think it requires 10, and the address is this one. And then let me just paste it here. And then okay, this is the address. Okay, and then and then this we have the method is join. So okay, let's go up. Yeah, so this is join, and the join parameters, of course, similarly is basically just a validator net address. Just take some string. For this one, it's just a test string, and you just print it, and you would have this chunk of code. So anyway, I just deploy this, call it, and then just wait for the message to execute. And you should call into, correct. And then this is success, means it actually calls into the IPC gateway already. Thank you.
Awesome. Thanks so much, George, for playing Will's demo for us. Last but not least, we have ZenGround 0. And are you ready to present?
Yeah, I'm ready. Thanks, Misty. I'm presenting something called a client contract, and it's being developed right now by the Lotus team in collaboration with the CryptoNet lab. So I want to leave like some high-level motivation and, I don't know, a description of how you could, who to point to this or how to get involved is like the most important top-level thing, because this might take a while to demo, and we should get the whole end-to-end picture first. So why would you care about this project? So if you've heard about data DAOs or the notion of implementing perpetual storage on top of Filecoin, then this project is working on a building block which might be of interest to you. It's basically an experimental project trying to make this sort of thing work right now on the FEVM technology that we have deploying later next year. And yeah, we have some prototypes which can do certain things which are interesting from a data DAO perpetual storage perspective. So I'll go a quick overview of the architecture here. So I think everybody here is probably familiar with the idea of a storage deal being initiated by a client, which is a great model and one that Filecoin currently uses. In that case, a client is somebody who's out there on the internet with a public key, who's actually making a deal with a provider. The idea behind this project is to try to extend that and think about what we could do making a smart contract be that client. So the very general idea is we have a contract which secures funding in some way and also secures some way to add up a set of CIDs which it's interested in storing, or a reference to data that it's interested in making a deal with. Then the basic model, the storage provider somehow finds out about this and then publishes a storage deal just like it would do today. And then this deal, because of mechanisms introduced as of yesterday in FIP44, the market actor can call into a general client contract, which can then authenticate the deal or say, no, this deal is no good. And then payments can be handled either through the contract or directly inbound through the market. So you could use like Phil Plus to pay for things too. So that is the basic idea. So making a deal with a contract. Yeah. So with that said, I'm going to try to walk through the basic flow on the basic code. Yeah, and I guess last thing, like before I get into that, we do have one contribution from a community member. More would be super welcome. If anybody's interested in building this sort of stuff, you can point them this way, or if you can leave any comments, questions on issues. Yeah, but I'll get into the code. So I'm still pretty new to Solidity tooling, so you might have to bear with me. On my right-hand terminal over here, I've got some local stuff where I'm actually just munging around Solidity style data and figuring out how to create data which we can use to interact with the contract. And then on the left out here, I have a instance which is syncing Wallaby. So Wallaby, in case you don't know, is the FVM testnet, which allows you to deploy FEVM contracts right now. And so we can interact with Wallaby directly in this terminal. So what I've done beforehand in order to get ready for this is I've created both the deal client and a mock market on the Wallaby testnet. So to create the deal client, I just took that repo we were looking at and I built this big Solidity bytecode thing to make the contract. And then using the great tooling from the FEVM team, I've created this contract. So there's 3 steps we're going to go through to make to take a look at the end-to-end flow. So the first step, we're going to add in the CID to the client. You can imagine there's many different ways that you could defer this to other contracts or to voting mechanisms or something like that. But for our case, we're going to do the most basic thing and just have a trusted key, add a CID to that client. The next thing we're going to do is make a mock deal. So things are still mocked out a bit because we need to flesh out actually implementing certain parts of the system. So the making the market actually call a user contract needs to happen, and then actually changing the flow of offline deal making to include this flow is something else we're working on. But for now, we're going to have a contract, this mock market contract, which is also deployed right here, which we can send a mock message which says, hey, publish storage deal. And the idea there is that should actually just be a provider who throws the publish storage deal onto chain the way they would now. Okay, and then the last step, we'll check to see that the deal has gone through by looking at the client contract. Again, this is mocked out because we don't have the tools we need yet on Wallaby to actually interact, but that's coming in like a week or two. But okay, so without further ado, I will get started on actually interacting with the contract. So the contract is here at this address. What we want to do is invoke it at its add CID method. So what we can do is run this command right here to create the parameters, which we can then send out to this contract. So Lotus chain invoke. Let's see, so it should be at this address. This is the address that the client contract is at. These are going to be my parameters. And then the last thing is, what is the method we're going to call? We want to call add CID. So that's this method right here from the Solidity tooling. And so, great. Looks like it's going to work because our gas estimation didn't fail. So now we're adding the CID, which the client will say, yeah, I'll make a deal with you on that. So in the meantime, that's going to take a while because Wallaby takes a while. I'm seeing some stuff in the chat. Cool, I can answer some of this stuff later. Hard hat should work. Yeah, Forge is just what I'm using. Just kind of learned Solidity stuff recently. So yeah, definitely willing to try different stuff. But while we're waiting for this to show up, so I have some data here. So what we need to do when a storage provider would create the deal, there would be some tools on their end which would actually create all of this data. But for now, for the purposes of like mocking out this mock market, we're going to send over this already serialized deal, which is Seaborn encoded. Basically, this stuff right here is exactly what the market actor sends over to the deal client today during sends over to like account actors today during like authentication of a deal. So this is like exactly the right interface to interact with the market actor that it will send to the client. And this basically is just a thin wrapper around a storage deal. So a storage deal is a few things, but mostly it's this CID here. And this is all in Seaborn bytes, so it's maybe a little inscrutable. But and then there's also this provider here at 66, which will be important later. So we're going to make this deal with the client once the client is ready. So let's see. Yeah, okay, good. So it is executed. The client now has added the CID to its set. And what we can do is create the parameters to send to the mock market. Again, this is what the storage provider would end up doing. So yeah, we need to encode the deal parameters, which are right here. So this is like the deal basically. And then we also need to give it the address of the client. And so let's just go and figure out what that is. I'm getting a little bit lost here. Let's see. So my client is publish mock deal. Yeah, okay. So we added the CID here. The Ethereum address of the client is this guy. Yeah, because we sent to 1434. Great. So we can send that right there. These are the parameters which will make the mock deal. So we're going to go Lotus chain invoke, and the mock market is at T01428. This would really be like the storage market actor, the built-in storage market actor. In the unmocked case, get rid of that OX. I think just double check. Yeah, D75 is the make a deal part. So great. Now we're going to publish that deal. And I see that we're almost going over. I'll keep going unless if somebody tells me to not keep going, I will definitely stop here, but I can try to finish quickly otherwise. So we're waiting for Wallaby to execute this message. Thanks, Misty. So we're waiting for Wallaby to execute this message. And the last thing we're going to do after that is we're going to check to see if the deal was made correctly by inspecting that the provider is listed in the contract. The contract state will tell us what deal has been made. So we are expecting to see provider 66 based on our deal structure right here. Our deal proposal was saying, hey, let's make will you make a deal for this CID with provider 66? And so this should be the thing which checks to see, does the Solidity contract have a provider which is storing this CID, and that provider is 66. So we can do this. The only thing that's going to change actually, so I think this should actually be the same bytes. The only thing that's going to change is this is where our contract is right now. Yeah, so hopefully I didn't just hit a raise condition, but the message looked like, the deal looked like it went through. And so now all we have to do is wait to see. If we get a 1, then it means that the provider was added. If we get a 0, then it means that I messed up the demo. But I promise we can make it get to be a 1. Yeah, so we can wait for that a little bit. Yeah, I can also take a look at some of the questions, if there was anything. Nice, okay. Looks like most of the chat was just people talking about stuff. Yeah, this is the problem with dealing with a live network. Things take a little bit of time.
I guess while that's running, do you mind answering like one question I have, or?
Yeah, I'd be quite happy to answer questions. I'm getting pretty bored here.
Yeah, so I was wondering if you have any plans, or did you consider yet integrating with the Filecoin Plus program and using this as like the backend for a platform to actually manage the Filecoin Plus processes involved and workflows?
Yeah, I
Did you-
think
did
there's
you
a lot of
consider it?
opportunity. Yeah, I've definitely been thinking about that. I think so the thing that our team first wants to build on top of this is some sort of a Filecoin state preservation thing. And in order to do that right, we need some sort of incentive to actually pay out for the deal. It seems like FilPlus is like pretty much the standard right now for doing that. So the hope is to leverage FilPlus directly. If we can get data cap to this contract, that's kind of the direction we're thinking right now. Of course, you could also pay directly with Filecoin. But yeah, there's other ideas about maybe like making clients very auditable by having all of their behavior specified in a contract, which could be appealing in the future of FilPlus. So yeah, definitely also open to hear more ideas there. And I guess just heads up, it looks like it worked. We added the provider, and so the deal went through. Again, when this is not mocked out, we'll actually see like the deal in the built-in storage market. But yeah, that's the completion of the demo. So thanks so much for listening, everybody.
Awesome. Thank you so
That
much.
was awesome.
Yeah. Well, that concludes the Mother of All demo days for today. And thank you so much to all of our presenters. For those that joined late and didn't catch the news, we have one more demo day on 12/15. So if you want to present, there is probably going to be 1 or 2 spots open. And that will be the last one before the Christmas break and the new year.